Radical expressions. Our objective is to simplify radical expressions. Why learn this? You can use a radical expression to find the length of a throw in baseball. Let's look at some vocabulary. A radical expression is an expression that contains a radical sign, much like what you see below. The radicand is the expression under the radical sign. So the radicand here would be L squared plus W squared. The radicand here would be 2GD. So we're going to be learning about simplest form of a square root expression. An expression containing square roots is in simplest form when the radicand has no perfect square factors other than 1, meaning you don't have like the square root of 25, because you can simplify that. That can be simplified to 5. The radicand has no fractions, meaning you don't have the square root of 7 over 16. And there are no square roots in any denominator, meaning you're not going to have 3 over the square root of 2. You're going to learn how to simplify these as time goes on. But for right now, simplest form of a square root expression is not going to have a perfect square, it's not going to have fractions as the radicand, and there's not going to be a square root in the denominator. So let's practice simplifying square root expressions. So in this first one, we have the square root of 2 divided by 72. So we want to simplify what's underneath the radical sign first. So 2 divided by 72 is 1 over 36. And now we can take the square root of the 1 and the square root of the 36. So the square root of 1 is 1, and the square root of 36 is 6. In B, it's a little bit tricky. Notice how you have two values that are separated by an addition symbol. When you have an addition symbol, you cannot simply cross off your exponents and your square root. You have to simplify what's underneath. So you have to simplify the radicand first, then take the square root. So we have 3 squared and 4 squared, which give us 9 and 16. 16 and 9 make 25, and the square root of 25 is 5. In a previous unit, we learned how to factor. So that's going to come in useful here. We have a trinomial. We have x squared plus 8x plus 16. More specifically, you have a perfect square trinomial. So when you have a perfect square trinomial and we factor, we're going to end up with x plus 4 times x plus 4. If you factored it out and did not realize that it was a perfect square trinomial, you might have had this underneath as the radicand. X plus 4, x plus 4. And then when you simplify this, this gives you your radical, so you have your square root of x plus 4, that quantity, squared. So now we simplify. Since this is one clump of numbers, we can cross out the 2 and the square root and end up with the absolute value of x plus 4. You couldn't do that here because they were completely separate, but here they were one clump, all being squared. Let's try a few more. So take a moment and pause the video and try these next 4 on your own. When you return to the video, the answer for each one will be revealed. And there you have it. So for this one, we did 256 divided by 4 to get our 64, and the square root of 64 is 8. For this one, 40 and 9 make 49, and the square root of 49 is 7. For C, we did 5 squared, which is 25, and 12 squared, which is 144, we added 25 and 144 together to get 169, and the square root of 169 is 13. For D, this clump here is being squared. So since it's being squared all together, we end up being able to cross off the 2 and our square root because they are opposites of each other. So we're left with the absolute value of 3 minus x. So now let's look at the product property of square roots. For any non-negative real numbers, a and b, the square root of a times b is equal to the square root of a times the square root of b. So essentially, if you had the square root of 4 times 25, you can combine them together to get the square root of 100, which is 10. It's also equivalent to separate it. So if you had the square root of 4 times 25, you could take the square root of 4 and then take the square root of 25, and you'd still end up with 10. Let's practice. So we have the square root of 18, and we're going to split this up. So when we split these up, we want to make sure we select at least one number that is a perfect square. So some factors of 18 are 9 and 2. So we have the square root of 9 times the square root of 2. Well, we know what the square root of 9 is. That's 3. And we can't simplify the square root of 2 any further. So we simply rewrite it. So your end result is 3 times the square root of 2. Now let's try one with variables. So if we break this down, we can simply state that we have the square root of x to the 4th times the square root of y to the 3rd. But we can break it up even further if we need to. Notice how the x to the 4th, if we were to clump things in pairs, we would have the square root of x squared times the square root of x squared. And then if we look at this one, we have a y squared and a y. Well, since it's by itself, we can cross off the 2 and the square root and have x, the square root, and have an x, the square and the square root, and have a y. But we can't do that here. We don't have a square root to play with. So we simply leave it underneath the radicand. So we have x squared times y times the square root of y. Now let's take a moment and try these next three. So pause the video, and when you return to the video, the answer for each will be revealed below. So this first one, we had the square root of 128. We can separate that into the square root of 64 times the square root of 2. The square root of 64 is 8. We can't really simplify the square root of 2 any further and not end up with a decimal. So we're just going to write the square root of 2. So our end product here is 8 times the square root of 2. So now let's look at 2b. So we separated our x's from our y's, and we have one pair and a leftover one. So we can cancel out the square and the square root. For x, we can't do that here. But with the y we can. We have a square and a square root. So we're left with y. So now we just kind of reorder everything so it looks nice and neat. So we have x times y times the square root of x. Now, this one was a little bit tricky because it's got numbers and variables all kind of mixed together. Hint: do your numbers separate from your variables and then combine them. So we have the square root of 48, which we can separate into 16 and 3. We know what the square root of 16 is, that's 4. And you can't do anything with the square root of 3. And your variables here, we have one set of 2, we have a pair, so we're going to pull one out. And then, we got a loner in here, so he's going to stay. Now that you have them both separate, we want to combine them together. So whatever is outside, we're going to multiply them. And then whatever is inside, we're going to multiply them and keep them inside. So we have 4a times the square root of 3b. So now that we've looked at the product property, let's look at the quotient property. So for any real numbers a and b, a has to be greater than 0 or greater than or equal to 0, and b has to be greater than 0. The square root of a divided by b is equal to the square root of a divided by the square root of b. So as a little bit of a further explanation, we have the square root of 36 divided by 4. So if we divide that out, we end up with the square root of 9, which is 3. Or you can take the square root of 36 and the square root of 4, which is 6 divided by 2, which is still 3. So you can separate it, or you can do it all together. Sometimes you're going to have to separate it though. So let's take a look at that. So for this one here, we have the square root of 5 divided by 9. So we can rewrite this to state it as the square root of 5 over the square root of 9. Now remember back when we stated that we can't have a square root in the denominator, so we need to simplify this. Well, what's the square root of 9? That's 3. So 3 is on the bottom, and can we do anything with the square root of 5? No, so we simply rewrite it. So we end up with the square root of 5 divided by 3. So now let's look at b. This one we might want to simplify first. So we have a to the 5th, and this is like saying a to the 1st. So our laws of exponents here, we'll end up with a to the 4th over 81. So that's still all underneath the radical sign. So now we're going to separate it. We have the square root of a to the 4th over the square root of 81. The square root of a to the 4th, as we've done previously, is simply a squared, and the square root of 81 is 9. So now take a moment and pause the video and try these next 3 on your own. When you return to the video, the answer will be revealed. And there you have it. Let's step it up a notch. So now let's try using the product and quotient properties together. So for example, in this first one, we can take it as the square root of 80 over the square root of 25. Some of you might have stated that we have the square root of 80 over 5, because you know that 5 squared is 25. However, we can still simplify this square root of 80. So let's look at the square root of 80. We can split 80 into 16 and 5. So the square root of 16 is 4, and we can't do anything with the square root of 5. So we just simplified our numerator. So we're going to kind of just put that right back. So we have 4 square roots of 5 on top, and then we're going to stick that back on the bottom because we already simplified that. And there's your end result. So now let's try this next one. On the top, we've got the square root of 4x to the 5th over the square root of 9. The square root of 9 is 3, but we might have to simplify this top. So we have the square root of 4x to the 5th, and we're going to separate this out. So we're going to have the square root of 4 times the square root of x to the 5th. Well, the square root of 4 is 2, and how many pairs do we have? Well, we have 2 pairs, so we have times x squared. We've got a leftover one, so we're simply going to just write that back down and keep them inside. So this was our numerator, so we're going to simply stick that on top. So we end up with 2x squared times the square root of x over 3. Take a moment and pause the video and try these next 3 on your own. When you return to the video, the answer will be revealed. And there you have it. This also ends our lesson on radical expressions.